Alright guys, welcome back to the IPC classroom. Once again, I'm Mr. Hawkins, and today we're going to be discussing types of chemical reactions, okay? So up to now, we've gotten the basics for chemical reactions, where the reactants go, where the products go, what the little symbols mean, coefficients, subscripts, all that fun stuff, alright? Now, there are different types of ways that chemicals react, and so we're going to learn about those today. The first of these is called a synthesis reaction, okay? It's also known as a combination reaction, but for our purposes, we're going to refer to it as a synthesis reaction, okay? It takes two different elements or compounds and mushes them together, okay? So if I have element A and element B, and I put them together, we make a compound called AB. You can see that by the chemical the equation right below. All right? Now, to get a real-world example of that, okay? If we take iron filings, and if we take sulfur and mix them all together, and you cook it, and it smells real bad, if you remember that, okay? It stinks, and it actually generates ferrous sulfide, which is FeS, okay? I know that's not on the page, but I assure you that's the synthesis reaction of iron and sulfur together, okay, to make a compound called iron sulfide. All right, pretty straightforward stuff, right? Synthesis, taking two, making it into one. Synthesizing them together, okay? The next of these is decomposition, okay? Decomp is basically the opposite of a synthesis reaction. So whereas in a synthesis reaction we had two and made one, in a decomp we have one and make two, all right? So it breaks down a big compound into smaller and smaller pieces, okay? Decomposition reactions happen all the time around us. Decomposing material is all done through decomposition reactions. Everything breaks down into smaller and smaller pieces until there's nothing left. Yeah, and so another example of this is the decomposition of water, all right? This is called electrolysis, all right? We can do this with electricity. We can actually split apart water and generate hydrogen and oxygen, okay? So hydrogen and oxygen from water. Break it into its two components, okay? Those are the key words there. So you break it down in a decomposition reaction, whereas in a synthesis reaction, you build it together, make it bigger, all right? Now, here are two kind of different ones. All right, we have a single displacement reaction, okay, and that's basically where one element is hanging out next to a compound, and that element switches places with one of the elements that was currently in the compound. Okay, so as you can see right here, A plus BC equals AC plus B. So basically, A displaced B or replaced B. Okay, that makes sense. They switched their positions in the chemical composition. All right. There are a couple of different examples of this that we've probably already used if we've seen the zinc and hydrochloric acid reaction, which didn't work in a lot of the labs. But if you've seen it, that actually is a single displacement reaction. Another one is adding magnesium to water, and that actually generates magnesium hydroxide and hydrogen gas. All right. So you can see the magnesium kind of switches places with one of the hydrogens and kicks it off. Okay? So a single displacement reaction, switching places with one of the others and letting the other compound or element kick off. Okay, now we get to the double displacement reaction. Okay? And this is where basically everybody switches partners. Okay? So we have AB plus CD yields AD and CB. So you can see A and C switch places with one another, and so now C is with B and A is with D. Alright, that's called a double displacement reaction. That's where both compounds switch their partners, okay? This happens a lot in liquids, alright? We actually noticed a double displacement reaction the other day when we did the yellow reaction. You remember whenever we flipped the thing over and it generated that yellow color? That is actually a double displacement reaction. It's the one that's below, okay? We have lead nitrate and potassium iodide switch places with one another and make lead iodide and potassium nitrate, okay? You can see the K and the PB switch places with one another. And everything's balanced on that equation. All right, so double displacement versus single displacement. Double displacement, the two partners switch with one another. Single displacement starts with one all alone, and he switches places with one of the compounds, all right? And see the difference between those two. It's very important, all right? That brings us to the big boy, okay? This is rough stuff. This is combustion, okay? It's a little bit tough. Explosions, fire, boom, kapow, right? All that stuff deals with combustion reactions. And in combustion reactions, we have an organic sample, okay, which means that it has C's and H's, okay? Or a hydrocarbon, which is added in the presence of oxygen to generate CO2 and H2O. Okay, those are always the products of combustion reactions: carbon dioxide and water, CO2, H2O. The products of combustion reactions all the time. Combustion reactions, though, kind of look like synthesis reactions in the fact that you have two that are hanging out together and they get all mushed up, but the products are nothing like what they were originally, okay? So it's kind of taking pieces of all the different types of reactions and mushing them into one giant stew, okay? But combustion, organic sample in the presence of oxygen to generate CO2 and H2O, okay? A hydrocarbon group, hydrogens and carbons, right, as you can see right here, added with oxygen to generate CO2 and H2O. All right, so those are the different types of reactions that we're going to be dealing with in this class, okay? We have synthesis and decomp, all right? They're the opposites of one another. Single replacement and double replacement, all right, where one switches in and all of them switch in. And then we have combustion, okay, just hanging out by himself where he does his own little thing, generating CO2 and H2O always, all right? So if you have any more questions about these types of reactions, please just let me know. Post a comment down in the comment section below, or come in for activity period tomorrow, okay? You guys have a great evening. We'll see you.